Hi there, welcome to edupediaworld.com. You're watching the videos on areas of parallelogram and triangles. So in this video, we'll discuss some more properties related to triangles when the two triangles are on the same base and they are between the same parallel lines, so how they can be related. Then we'll discuss the theorems related to triangles. Then we'll discuss some of the examples, how we can use these triangle theorems when they are on the same base to solve some of the questions. So let's get started with the first introduction. Now, it says that triangles on the same base and between same parallels are equal. So let's see how we can do this. See, we have learned in the previous video that if we have a parallelogram AB, CD, and we have a triangle like this, let's say like this, right? So let it be D. Now, if this is a triangle and let this is a point P. Now, you can see clearly this triangle. We have learned in the previous video that if this triangle they have a same base and they are between the same parallel, so area of triangle APB will be half the area of parallelogram ABCD, right? Same way, when we have two triangles, let's say we have a triangle ABC over here, and we have another triangle BPC over here, and you can see that both the triangles have the same base BC. Let's say triangle ABC and triangle PBC. They share the same base BC and they are between the same parallel lines AP and BC. AP and BC. So when the two triangles they have same base and they are between the same parallel lines, they have a same area. So we can say that area of triangle ABC will be equals to area of triangle PBC. So this is how we can use the triangles when they have the same base and between same parallel lines. So let's discuss the theorem related to this now. The theorem says that two triangles on the same base or equal bases and between the same parallel lines are equal in area. So let's see how we can prove this. Now, the point you have to note it over here is that the base can be same or they can be equal. So let's discuss how we can use this now. So let's draw the first one parallelogram. So let's say we have a parallelogram like this. So parallelogram A, B, C, D, and let's say we draw a diagonal AC and altitude AN now. So we can say that triangle ADC is congruent to triangle ABC. Why? We all know that ABCD is a parallelogram, right? And AC is a diagonal, right? So diagonal divides a parallelogram into two congruent parts. So we can say that a triangle ADC is congruent to triangle ABC. Similarly, now you can say that area of ADC will be equals to area of ABC, right? Since if the two triangles are congruent, the areas are equal. Now, again, we can write then area of ADC will be half the area of ABCD, right? Now, area of ABCD, why area of triangle ADC is half the area of ABCD? Because they are on the same base CD and they are between the same parallel lines AB and CD, right? Now, so area of ABCD can be written as, if we take base DC and altitude AN, so it can be written as DC into AN, right? Now, therefore we can write area of ADC equals to half the base DC and times corresponding height AN, right? Now the theorem says that it should be either same base or equal base. Now if you consider this triangle ABC, right, they AB is equals to CD, right, because in parallelogram opposite sides are equal, so we can write area of ADC equals to half AB into AN also. Now, right, now if the areas are equal, right, and the bases are equal, so we can also say that their corresponding height will also be equal then, right? So then only the area can be equal then, right? So this implies it, this proves that if the two triangles are on the same base or in their equal bases and they are between the same parallel lines, why they are between the same parallel lines? Because they have equal altitude, so they are equal in area. So we can write area of ADC will be equals to area of ABC. So this is how we can prove that if the two triangles they have a same base and the equal bases and they are between the same parallel lines, then the areas are equals. So let's discuss some of the questions, some of the examples, how we can use this theorem to solve the examples. Now, the first example says that show that the median of a triangle divides the triangle into two equal areas. So let's see how we can do this. First, we need to draw a triangle. So we have a triangle like this, A, B, and C. So let's say this is a median, or D. We draw a line like this. Let's say we draw an altitude AN also, right? Now, so we need to prove that area of ABD is equals to area of ADC, right? Now, so let's see how we can solve this. Now, area of ABD will be half base, so base is BD into height is AN, right? Now, since D is median, so median divides the side into two equal halves, so we can say that BD equals to CD. So we can write area of ABD equals to half. Instead of BD we can write CD, so we can write CD into AN. So area of ABD will be equals to, now this becomes the area of triangle ADC. Why? Because the base is CD and the height is AN, so altitude remains the same, so it will be area of ADC. So this is how we can prove these type of questions. So let's discuss the next example now. So this example is very important example from the exam point of view, so you have to watch this example very carefully. Now in this example it's given that in figure ABCD is a quadrilateral, so ABCD is a quadrilateral, you can see properly, and BE, so this line is parallel to AC and BE meets DC at E. When DC is produced they meet at E. Now we need to show that area of triangle ADE, means this triangle, right, is equals to area of quadrilateral ABCD. Now, so let's see how we can prove these type of questions. Now you can see properly that area of BAC and area of EAC are equal, right? So let me use another pen to highlight. So BAC is this area, you can see properly, and EAC is this area, right? So you can see properly they are between the same parallel lines. BE is parallel to AC and they have a same base. AC, same base AC, right? So we can say that area of BAC is equals to area of EAC, right? So now if you can see properly, quadrilateral ABCD area of quadrilateral ABCD can be written as area of ADC plus area of BAC, right? Means ABCD can be written as area of this area plus area BAC, right? Similarly, area of ADE can be written as ADE, this area can be written as area of ADC plus area of EAC, right? So in these two, you can see properly, we have both common area of ADC. Now, let it be first. Now, if we add area of ADC to both sides, so let's see what we get. So we get area of BAC plus area of ADC equals to area of EAC plus area of ADC, right? So now area of BAC plus area of ADC, it will become area of quadrilateral ABCD. So we can write area of ABCD, now which is equals to area of EAC plus area of ADC will become area of ADE. So it will be area of ADE. So this proves that area of quadrilateral ABCD is equals to area of triangle ADE. So this is how we can use the theorems to solve these type of questions. So thank you once again for watching this video on edupediaworld.com. Keep watching further videos. Have a nice day.